Hello everyone, I'm making this Patreon only video to keep you guys up to date with what I'm doing currently. As I mentioned in my previous video at the end, I'm not going to be doing weekly videos for a little while because I want to focus on slightly more complicated projects and spend a bit more time on them to make one single video. Now what I've been up to this week is I'm currently working on an ABS system for a pedal bike, basically anti-locking brake system, like what you would have in your car, and some modern motorbikes also have it. And what I've been doing this week is I've basically built a rotary encoder to measure the rotational speed of the wheel more accurately than if you're using a regular bike speedometer. A regular bike speedometer only measures the speed that you're travelling every one wheel rotation, which is not enough if you're doing an ABS system, because if the wheel locks you have no speed measurements. So what I've got here is a 3D printed plate. If I just stop it. I've got a 3D printed plate with 60 slots cut in it, and at the bottom here there is an infrared beam sensor, which when the beam is broken or not broken, it will send a high or low signal to this Arduino. Now I can put the data up on the screen about here. It's basically data logging to my computer, showing the velocity and the acceleration of this wheel. The blue line, which you can see just slightly higher there, is the velocity of the wheel. The red line is the acceleration or deceleration, depending if it's going up or down. And the green line is basically a set line I've made just to simulate when the wheel decelerates quicker than that line, it will send off this buzzer, which you may have just heard buzz a little bit. So I'll just give you a quick test example. If I put it stationary, you should be able to see the lines try to go to zero. They don't quite go to zero because there's some filtering involved to try and make the noise a bit smoother. I can't get a perfect signal, speed signal, because it can only read every pulse. So the actual speed values are coming in pulses rather than a smooth continuous value. But if I spin it up, you should see the red line increase as well as the blue line increase. Then when the velocity goes constant, you should see the red go back down to zero. And then if I try to break it, you should see the red line go down, and same with the blue line. Now because the red line didn't go below the green line, it didn't set off the buzzer, which is to simulate the ABS. If I spin it up again and then I do a hard brake, should see it go below the green line and the buzzer goes off. Let's try that again. I'll spin it up a bit quicker. We'll see if we can get a few buzzers in. So wait for the thing to be as fast as possible, and decelerate, decelerate, and decelerate. So we've got 4 ABS kicking in that time. Now this system is called a deceleration ABS control loop. It's one of the most simplest forms, but this is not actually what happens in an ABS system in a regular car, because basically depending on the surface that you're braking on, you know, if it was tarmac, wet tarmac, grass or ice, the deceleration rate will change. So just having a constant deceleration rate as the ABS limiter doesn't work for when you're changing surfaces that you drive on. So I've been doing some research into how actual ABS systems use in modern cars, and it's a really complicated control system. I will post a link to the paper I've been reading if you guys want to do some more research into it. It's quite complicated maths and control loop, Laplace transform stuff, but in the end I'd really like to implement this into the ABS system I'm building. In terms of the mechanism that I'm going to be using to reduce the braking for when the ABS kicks in, I'm going to be using cabled brakes, and I'm going to be using a stepper motor like this to basically release the tension in the cable. I was originally thinking of having the brake as almost like an electronic switch, and then have a fly-by-wire through to the stepper motor which will pull the cable brake. But the problem with that is that if there's any kind of error in my code or an electronics failure, it could send me over the handlebars. So instead I've come up with this mechanism. It's not in CAD, I haven't put it into the CAD software yet, but I've drawn it somewhere. And essentially, the stepper motor will only have control over the release of tension of the cable. So if the electronics fail or the code goes wrong somewhere, all that will happen is my front brake won't work. I'll still have the back brake, but at least I won't be sent over the handlebars. So yeah, that's a good thing. Right, I'd like to thank you very much for watching this very short update video. I hope you guys enjoyed this video. I just thought I'd do a quick short update video because I don't really want to leave you guys not seeing any information on what I'm up to. Next week I'm hopefully going to finish the design on the actual braking mechanism and possibly get some testing done. I would like to test this deceleration mechanism where it simply, it didn't work that time, where it simply sets off the buzzer at a certain deceleration rate. But I have a feeling that this is only going to work if I fine tune it for the surface I'm testing on. And then if that does work, then I'll move to the slightly more complex coding. Thanks once again for watching, and I'll hopefully have another update video next week. Goodbye.